Hello everyone, welcome back. So we don't have too much to do today. The structure of this week's going to be a little bit different than the other weeks. The plan is we're going to have a 1-hour lecture tonight, and then on Thursday morning we're going to have what I'm calling work period. So I know that people want extra office hours. People are all gung-ho. They want to do the midterm. So on Thursday morning, I'm going to get a cup of coffee, and then I'm going to answer your questions. Okay, so I invite you to come bring some questions that we can talk about. We have covered the course content already, so we are ready for the midterm. We just have a little bit of extra work to do tonight about Taylor polynomials. Okay, so we're going to do a lecture tonight, and then Thursday morning is going to be kind of like office hours with a lot of people. Okay, I want to show you some things on the blog. Is that all right? There we go. So let's try this. Oh yes, so we had the mock midterm last Friday. I see some familiar faces from the mock midterm. That's nice. If you haven't, if you didn't come out and write it, I really recommend trying it out. Okay, the mock midterm is the best study guide for the real midterm. Computer, go. Okay, all right, so, hi, welcome folks. Okay, so here's the details about what we're going to be doing this week. So tonight we're going to be doing Taylor series and a bit of review. And then we're going to, on Thursday, we're going to have this class survey and work period. So please come on Thursday. There's going to be a survey just to see how the course is going. You know, is the homework too easy, too hard, this kind of thing, so that halfway through the course I can see how your experience of it is. And we're going to have work period instead of lecture. So bring some questions. We can answer them, and you'll get a bit of practice in on Thursday morning. Okay. Then on Friday we have the term test. Okay, so the term test is happening in these two rooms, IC 130 and IC 230. If your last name is A through V, please come here. Okay, you're in the usual room. So if your last name begins with A, B, C, D, etc., you're in this room. And if your last name begins with a W, X, Y, or Z, you're in the other room. Okay, so there'll be a split. The term test policy is the following. So I know that a lot of people like to go out for sushi the night before a test. It's very nice, gives you food poisoning, then you don't have to write the test. Okay, so if you are for any reason feeling sick, you're feeling stressed out, you don't want to write the test, please get a medical note. You also need to fill out this verification of student illness or injury form. Okay, so the form is available online. So if you're sick, you know, you're not able to write the test, please fill out one of these. Get your doctor to fill out one of these. Okay, so this is the form that you'll have to submit if you miss the test. Okay. Once you've filled out that form, please email it to me, and do that within 24 hours of the test. Okay, so at 5 p.m. the clock starts. Okay, by 5 p.m. the next day, if I don't have your medical note, you will receive a 0. Okay, it's 30% of the course grade. So please, if you feel sick, fill out the form, get it done. One other thing is I tried to schedule the test to avoid Ramadan, but I forgot that there's the day after Ramadan, which is another special day. So if you're celebrating Eid with your family, if you're a practicing Muslim, please let me know. That's totally fine. I totally get it. So if you're celebrating Eid or any other religious observance, please let me know and we'll set up an alternative sitting. Okay? So very important there. Okay, the last little bit of notes here is that I'm going to be traveling the week after reading week. Okay, so I decided to take an extra long reading week. No, that's just the way the conferences worked out. But anyway, so the week after reading week, I won't be here. There'll be 2 people substitute teaching for me. One is my good friend Yvonne, and the other is my great friend Ray Grinnell. Okay, so the week after reading week, 2 guest lecturers will come in. On Tuesday night, we'll have Yvonne, and then Thursday morning, we'll have Ray Grinnell. Okay, so both really expert mathematicians. That's way in the future. Okay, so that's the week after reading week. Okay, are there any questions or thoughts? Questions, thoughts about policy? Okay, so the midterm is worth 30% of the term mark. It's a very large portion of the grade. I want you to treat it like it was a practice exam. Okay, it's very much like an exam. I want everyone to come out, write it with the best of their intentions. The things I recommend practicing, I recommend looking over the mock midterm. If you haven't looked over it, it's available here. Okay, so the mock midterm is online. I recommend trying this out if you haven't tried it. The other thing I recommend doing is the homework. The assigned questions. Oops. Yeah, so the assigned questions are in the syllabus. A couple of people have come to office hours with this thing like totally filled out. Good job. Anyone who's using the sheet of paper, that's awesome. Keep doing the good work. So these questions, I've tried to select a lot of them, or questions that are very much like them, for the midterm. So if you looked at the mock midterm, there's a lot of questions from this list. So expect that level of difficulty. Okay, very good. Yes?
Does this mean we're not getting solutions for the mock?
Hmm?
Are we not getting solutions for the mock?
No solutions. Yeah, no solutions. Right, so why do I have this policy, no solutions? Right, it's in the course syllabus. Why are there no solutions in this course? Because I've found that when I give people solutions, they look at it, they say, oh yeah, I understand this. And then you can study like 100 pages an hour. You can study really, 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 really fast. So now I say that you have to come and ask questions. Okay, you can email me questions. You can ask me questions. You can ask your TA questions. So if you've got a problem that you're stuck with, please email or talk to your TA. Okay, any other questions or thoughts? Okay, very good. So that's what I wanted to say about that. There's a little video of me saying all this stuff, if you want it. Okay, sweet. Okay. Okay. So we have to say a little bit more about Taylor series. Our presentation of Taylor series last Thursday was very rushed. Okay, so what's the idea of a Taylor series? The idea of Taylor series is to express a function as a limit of polynomials. Polynomials are sort of the nicest functions we have around. And we're going to take our arbitrary function and write it as a limit of polynomials. So how does this look in one dimension? Okay. We've got x0 plus h, and we write it as a limit in the following way. Okay, so we write it as a limit of polynomials. Okay, and I want to motivate this definition a little bit. I want to say a little bit more about why we define things this way. Okay, why do we define the Taylor polynomials in this way? So the idea is if something is a polynomial, then it should be its own Taylor series. Okay, so polynomials should be their own Taylor series. Okay, so let's do an example to see what that means. Okay, so we're going to find the Taylor series of this polynomial at x0 is 0. Okay, so we'll apply this definition for the case of this polynomial. Right, so in order to apply the definition, we take the derivatives. So our 0th derivative is the function itself. The first derivative, we get 4x plus 3. Okay, and then the second derivative, we get 4. Okay, so now we've calculated all of the derivative information we need. So let's put it together. Oh, I guess one last piece of information. Right? At 3 and all higher order terms, our derivative will be 0. Okay, so now we put the information together and use this limit. So we get 1 over 0 factorial. Then we've got our first derivative is 3. Okay, plus 4 over 2 factorial x squared. Oh, sorry, these should be h's. Okay, and when we do the arithmetic, we get this guy, and a little bit of rearrangement gives us this. So we get that this guy is its own Taylor series. Okay, so where do the factorials come from? Why do we have these factorials? We have the factorials in this limit so that the derivatives work out. So that this, when we take the derivative and evaluate it at 0, we get 1. So let's see. Right? Why do we have these factorials? Right? If we take the nth derivative of x to the n, when we take the nth derivative of x to the n, we get n factorial. So so we have those factorial terms in there to cancel out the operation of taking n derivatives. Right? When we take n derivatives, we get n factorial. So these factorials here are there to cancel out these derivative terms. Okay, very good. So that's why we do things this way in one dimension. Now I want to spend a little bit more time on the multivariable situation. Okay, so by analogy with taking n derivatives here, I want to ask, okay, what's this derivative here? We've got d cubed dx squared dy. So we're going to take one derivative in y and then two derivatives in x. Okay, so let's take the derivative in y. And we're going to write that as x squared times 1. Then we take the derivative in x. Okay. Now we take the derivative in x again. And we get the following thing. Now I want to think of this as two factorial times 1 factorial. Okay, when we take these iterated derivatives, we get things that look a lot like the derivative over there. So to state Taylor's theorem in multiple variables, I want to spend a bit more time on multi-indices. Okay, so a multi-index is a list of numbers. Okay, and we're going to define several things associated with a multi-index. Okay, so if we write absolute value bars like this, we add up the numbers. Okay, if we write alpha factorial, then we multiply the factorials. Like this. Okay. What else do we need? Oh, yes, we need alpha derivatives. Okay, so if we write f sub alpha, then we've got n1 copies of the first variable, n2 copies of the second variable, and k copies of the last one. Okay, so it's a big, complicated piece of notation. The last piece of notation we need is the following thing. X to a multi-index okay, so this is a lot of notation all at once. We've got absolute values for multi-indices, factorials, derivatives, and these polynomial terms. Okay, so I want to use these terms to define Taylor's theorem for multiple variables. Okay, so let's write it sort of by analogy, or the original. Okay, now we sum over all multi-indices with alpha equals to k, and we sum the following thing. Okay, so we can see that these look quite similar, right? Here we've got many possible multi-indices, so we sum up over all multi-indices. But other than that, the two formulas look very similar. Should have a vector bar. Okay, now I want to say a couple comments about the second order ones. Okay. Okay, and I want to fix a mistake I made with this formula last time. So we'll say where the mistake is. Okay, so if we're taking the second order Taylor polynomial, we add up everything up to second order. Okay, so let's write out what those terms are. All right, so let's just do the two variable case. Okay, so we get okay, so recall multi-indices are lists of numbers. So if we have the 0, if we have both of these guys adding up to 0, there's only one way for that to happen. Okay, so we get here. So that's our k equals 0 term. Right there, we have the multi-index equals to 0, so both entries must be 0. Okay, now let's do the k equals 1 term. Okay, so there's one way in which we can have k equals 1. Here's another. Right, so if we want a multi-index of size 1, there are two guys that do that. Okay, and now we'll write out the k equals 2 term. Okay, so lots and lots and lots and lots of symbols there. There's tons of things going on in that expression. So I want to simplify this expression a bit, or say what all the multi-index technology is doing there. Whoops, dang it, that was the wrong one. Oh. Okay, so to use all the multi-index terms, what do we get? Okay, so here we get 0 factorial times 0 factorial. So that'll give us f of x0 times 1. Okay, now we look at these terms. This is the derivative in the first coordinate, so that'll be an f of x. Okay, now here, this goes on the exponent of x, this goes on the exponent of y, so we get an x. Okay, here this goes on the exponent of y, this goes on the exponent of x, so we get a y here. Okay, now for the second order stuff, we get 2 derivatives in the x direction. Now the 2 goes on to the x, so we get x squared. Okay, so that takes care of, that takes care of this term. And now here's the last term of our second order. Okay, so the mistake I made in Thursday's lecture was the following. Okay, so in Thursday's lecture I said we needed xy and yx. Clairaut's theorem tells us we don't need that term. Okay, we can just do with one of them. Okay, that one term will give us all the information we need. Okay, so this is our correct formula for the for the second order Taylor approximation. Okay, so we should use this formula a couple times. Oh yes, and I was looking at Professor Moore's old midterms, and he's like, compute the 6th order, Taylor approximation. It takes so long. Don't worry, so we're just going to see 2nd or 3rd order, okay? So 6 is too much. So let's do a 2nd order example. Okay. Okay, so let's see second order Taylor approximation for cos x minus y. Okay, so we need to calculate all these derivatives here. So what do we get? We get, if we take the derivative in the x direction, we get negative sine x minus y. If we take the derivative in the y direction, we get sine x minus y. We get that minus because minus by minus is plus. The reason for this we will not discuss. Very good. So we take the derivative in x again. And we get negative cos x minus y. Okay, and now Clairaut tells us we only need one of these two terms. So we only need fxy, which is derivative of this, so that'll be cos. Is that right? Take the derivative of this in x? Yes. Okay. So there's all of our second derivative information. Oh, geez. Yeah, okay. That's multi-indices. Yep. Shh. Let's see. I take the derivative of this. So yeah, that'll give me cos. Yes, thank you. Good. Good. Good, 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 good. Yes. Any other questions or typos? It's good that we get the typos now before we go on in the example. Right. Okay, so plugging all of our data in here, right? We plug in all of our data. We get cos 0 minus 0, right? So that'll give us a 1 there. Then we get from this f of x term, or sorry, f sub x, those first two terms, we get plus 0x plus 0y. We put in here, we get negative 1 minus x squared. We put in here, we get negative 1. Let's see, those should be over 2. Okay, and then we get okay, are there questions or thoughts there? Maybe any typos spotted? Okay, so the process of getting these Taylor approximations is we start with the abstract nonsense. If we had to do third order, we'd write out all of the multi-indices of length 3. We'd put them into here. We'd compute all the derivatives up to third order. We'd plug in our base point, and then we'd get our polynomial. Okay? Are there questions or thoughts about that example before we go on? Okay, so the general formula okay. Everyone's very jazzed. This general formula is built okay. The general yes, sure. Right. Okay. So yeah. So I put in here, and I should get cos. So I should get 1. Yes. Key. Very good. Right. I would lose a mark on the midterm for that. Maybe I'd lose 5 marks. I don't know. Good. Okay, so the closing piece of advice I want to give about midterm taking is we're going to write the midterm with our brains, and we're going to write it with our bodies. So on the day of the midterm, please take care of your body, if only on that one day. Okay? So before the midterm, please sleep. Every exam, every time I go into an exam, I hear someone saying, "Yeah, man, I pulled this all-nighter. Like, I can't pay attention right now." Don't be that guy. So sleep well. Okay. I always used to get a big venti Starbucks before an exam. Don't do that either. That was a stupid idea. Okay. So if you're all wired on caffeine, the exam won't go well. The other thing is eat lunch and breakfast. Okay. In order to get ready mathematically, I think that the best practice I can suggest . Okay, try this, and then the homework questions. Okay, very good, folks. So Thursday morning, we're not going to have lecture in the usual sense. Please bring some stuff to work on. I recommend coming out because you'll get an opportunity to chat with other people about questions. Okay, thank you very much. Yep.